Do you guys like this new note thing?
Yes.
I love it. I hope you love it. So 3-6 is a kind of a new concept with inequalities. They're called compound inequalities, okay? And what you need to know, a compound inequality is two distinct inequalities, distinct meaning different, okay? So two separate inequalities that are joined by the word, and there's two different possibilities. You can join them with the word and or the word or, okay? And when you join them with and, it's gonna look different than when you join them with or, okay? Think about if I said, I'm going to the movies with Landon and Zeke. They're both going, right? If I say I'm going to the movies with Landon or Zeke, I'm not going with both. They don't both work out, right? It's this one or it's that one, okay? So the inequalities are gonna look different with this. So I tried to give you, this is a picture straight out of the book because I feel like they did a good job with color and how things lay out here. But notice this, it says the graph of a compound inequality with the word and, okay? So this is our and, contains the overlap. So with and, there is an overlap to form the inequalities, okay? So look at this setup. No, will you put your earbuds away for me, please? Thank you. If I have x is greater than or equal to 3, so basically the inequality they're going to give you, well, we'll get there. Never mind. Let's just start here. X is greater than or equal to 3 looks like this, right? It's a solid dot, and the arrow's going this way. If I then graph...
I did that wrong.
Bummer. If I then graph x is less than or equal to 7, that's a solid dot here, and my arrow is going to the right. So you have these two separate things, but we want both of them to be true. So in order for both of them to be true, I need to find the overlap between those two. And the overlap would be this, a solid dot at 7, a solid dot at 3, and this line in between. Those are the only points that the blue and the red have in common. So we don't want to keep going this way. We don't want to keep going this way because only one of the two graphs does that. We want both of them to be fully true, okay? So it looks like that. The or problems, so if you look up here, graphs that are joined with or, both of your graphs are going to be true answers, okay? So each graph of the two inequalities that form the compound inequality will be your answer. You'll use both of them, okay? So that means if I set up my x is less than, sorry, that's red. X is less than -2, that's an open dot at -2, and it goes this way. My x is greater than or equal to 1 is a closed dot here, and it goes this way. So then my answer could be the red or the blue. So anything that falls in the red or the blue can be an answer, right? So my answer then is this green, open dot with an arrow to the right, closed dot, sorry, that's the left, with closed dot at 1 with an arrow to the right for this. So if it's joined with or, I always tell people think of it like the oars in a boat, right? Your oars go out of the boat. So your or problems are gonna go like this. Your and problems come together. So wherever your points are, you're gonna shade everything between for and, okay? You're gonna go away for or. Does that make sense? Okay. Let's talk about this a little bit. So when it is an and problem, the beautiful thing about it just got really hot. Okay, do you think I'm in menopause already or what?
Sorry.
I'm not there yet. All right. Oh, that's not the highlighter. That's a pencil. Okay. So and, okay? You can write these and problems as one big inequality. You cannot do that with the or problems. So here's the deal. If I'm saying x is greater than or equal to 2 and x is less than or equal to 4, that means it's going to be between 2 and 4. So you put your smaller number on the left side, your bigger on the right side, and then you just got to make sure you have the right symbols. If my x is in the middle, think about this one. I had x is greater than or equal to 2. So if I'm flipping that around, now it needs to say 2 is less than or equal to x. And then my x and 4 are in the same place as they were, x before the 4. So that symbol is going to stay the same. When you put these together, you will never have this. Okay, it's always going to be the smaller on the left, the bigger on the right. This will not happen. You will always have less than or less than or equal to. Okay, because your less than stuff will be on the left and your greater than stuff will be on the right. Does that make sense? So if I gave you an and problem, I'm just going to go over here. Let's say I told you that x is greater than or equal to 5 and x is less than 16 or 10. Your setup will be 5 on the left, smaller number on the left, 16 on the right, my x in the middle, and now you got to determine your symbol. What symbol is going to go here? Less than or equal to, right? What symbol is going to go here? Less than, right? This symbol. So it's between 5 and 16. Well, because you're flipping your order, right? So you're flipping this one around because you want the smaller number before the variable. So we can just write it as one big one. Now, I don't need you to do that. You don't have to write it as one. So if that stresses you out and you feel like I'm going to do something wrong, that's okay. You don't need to. I'm just saying it is simpler just to write it as one big thing rather than have to write multiple. Okay? Okay, so let's turn this first example into an inequality, a compound inequality. So it says, what compound inequality represents the phrase, and then graph it, okay? So this is all real numbers that are greater than -2 and less than 6, okay? So and problems are the ones that you can write as one big one, right? If you don't like that, we'll do it the other way first. So it says all real numbers that are greater than -2. So you would say x, that's our all real numbers, is greater than -2. And what would my other one look like?
Less than.
X is less than 6. Okay? It's an and problem. Do and problems meet in the middle or go out?
In the middle.
Oars go out, like the oars on a boat, right? And problems go together. So you're going to set this up. If you want to write it as one inequality, it would be -2, x, and 6. What are your two symbols going to be?
The other way. Less than.
Less than. They're both going to be less than. So -2 is less than x, which is less than 6. So you may write it like this, or you may write it like this. I don't care which one you do. They're both correct. Okay? But then you need to graph it. So you have a -2 and you have a 6. Are these open or closed dots?
They're open.
They're open. There's no bar underneath, so we're going to keep them open. And we already said we shade where?
Going to the left.
In between, right? Because technically, x is greater than -2 would look like this. X is less than 6 would look like this. We only want the overlap. So your graph is just this, okay? Don't use this as your graph. If you want to graph up above just to see where the overlap is, that's fine. But we're going to do, for and problems, just what's in between our two numbers, okay? Yeah.
So say they're both less than, then you just do a less than?
They won't be both less than. One will be greater than and one will be less than. Always. Yeah. Yeah, I can show you in a little bit why if you want to see like the explanation behind it, but the ones I give you and the ones the book gives you will always have one of each set up so that you get an and problem or an or problem. Okay? Okay. This one says all real numbers that are less than 0 or greater than or equal to 5. So this is an or problem, which means our shading is where? Outward, right? We're going away from the numbers. We're not meeting in the middle. All right, so this would be what? X is less than 0 or X is greater than or equal to 5. Okay, so that's how we would write the inequality. When it's or, you cannot write it like this. You cannot write a joined one for or because it doesn't make sense. It doesn't meet in the middle anywhere, okay? So you have a 0 and you have a 5. Is it going to be an open dot or a closed dot at 0?
The first one's going to be open.
It's going to be open at 0 because of this. It's going to be closed at 5. Pay attention to that because a lot of times it's 1 and 1. It's not usually the same. I mean, it can be the same, but it's often something different. Okay, so if X is less than 0, where am I going from 0? Left or right?
Left.
To the left. Okay, if X is greater than or equal to 5, where am I going for the 5?
Right.
To the right. Okay. So just remember, if it's or, you should have oars coming out of your boat, right? Just like we're rowing a boat, oars go out to the side. Questions on that?
Keep going.
All right. So we're going to do a couple with and here. And these and ones are beautiful in that there's a really simple way you can solve them if you don't want to do extra work, okay? So notice there's two symbols, and we want to solve for M. Right now, M is not isolated in the middle. We want to isolate it. We want it just M in the middle. So think about if I were to ignore this whole part of the equation, of the inequality right now, how would you solve that inequality?
You have to combine. You have to add 4.
You would add 4. Okay, here's the rule. Whatever you would do, you do on 3 places because we have 3 parts to our inequality. We have the middle between the 2 symbols, and then we have the left and the right. Okay, so if I would add 4 here, then I need to add 4 on the left, and I need to add 4 on the right. And what I'm left with is an M in the middle. This is 0. Sorry. Okay, and then you just bring your symbol down. We didn't divide by a negative. We didn't multiply by a negative, so we're going to leave our symbols as they are. And then you simplify. What's negative 3 plus 4?
1.
That's 1. What's negative 1 plus 4? 3. So this answer is saying that M is between 1 and 3, including the 1, not including the 3, right? So if I graph this, I have a 1, I have a 3, my 1 is closed, my 3 is what? My 3 is open, okay? And here's the thing, you guys. If you don't remember the whole and is together and or is apart, that's okay because you can just graph each one individually. I can graph M is less than 3, and then I can graph 1 is less than or equal to M and just see where they overlap, okay? So you can do that. I just think it's way easier if you just remember this is an and problem, and problems meet in the middle. So your graph would look like this. Okay? Okay, so now a two-stepper. Look at this one. If I want to isolate y, what's the first thing I would do?
Divide.
You would add 4. Add first, then divide. So we would add 4, but you have to make sure you do it in 3 places. Right? We have a line here and a line here. So if I add 4 here, I need to add 4 on the right, and I need to add 4 on the left. And I'm left with 2 is less than, what's in the middle?
3y.
3y, which is less than 18. Okay, now how do I isolate y?
Divide.
Divide by what? Divide by 3. So if I divide by 3 in the middle, I need to divide by 3 on the left and divide by 3 on the right. 2 divided by 3 is not a nice number, so we're just going to leave it as a fraction. 2/3 is less than, this is 1, so just y, which is less than what? That'd be 18 divided by 2. 18 divided by 3 is 6, right? So this is your answer. So if we want to graph that, 2/3 would be on the left, 6 would be on the right. Are they open or closed dots? Open for both. And it's an and problem, which means in between. That's your graph.
Yes.
Okay.
More to go. I'm so sleepy.
You can do it. Okay, last one. Inequalities with or. Okay, think of a rowboat. You have oars, right? Oars go out of the boat. What are the solutions to these two? And this one's nice in terms of you're just solving two separate inequalities and your answers are your answers and you graph them, okay? You don't have to think about overlap and anything like that. There won't be overlap. You solve both, you graph both, you're done, okay? So if I look at the one on the left here, okay, so this one here, what's my first step? We're going to take away 2 on both sides. So I get 3t is less than -9. Then what?
You divide.
By
3.
divide by 3. So t is less than -3. Okay, that's part of my answer. But it's an or problem, so I need to know or, and I solve the other one. How do I solve that one?
Subtract 5.
Take away 5. Okay, so I get -4t is less than -4. Then what?
You have to divide by -4, but you have to switch the symbol.
Good job. Divide by -4. When you divide by a negative, you flip it. So t is greater than 1, okay? This is your answer. T is less than -3 or t is greater than 1, okay? So when I graph that, I have a -3 and a 1. Open or closed dots? Open on both of them, right? So this is going to be an open dot at -3. And which way do I go with it? Left or right?
Left.
To the left, right? Oars go out of the boat. At the 1, open or closed dot?
Open.
Open dot, and I go where?
Right.
To the right with it. Okay, so and comes together, or goes away from each other. Pay attention to open and closed dots, and that's what you're doing. Questions?